Hello and welcome to this third video in our lecture on user authentication with passwords and biometrics. In this video, I want to talk in more detail about the type of forward search attacks we mentioned in a previous video and some other attacks on the password systems. So this particular attack we want to spend some time on is called an offline dictionary attack. And basically the way this works is we assume that the attacker has obtained a copy of the system file that contains all of the passwords of the authorized users on that system. So basically, the system file is made up of records that, so each record contains basically the user ID of a particular user and their hash code, meaning the hash code of their password, and so on and so forth for all the users in the system. So this is a file that should have been protected, but somehow security was not tight enough, and therefore Trudy was able to access this system password file. Now notice the file at least does not contain the actual passwords, just the hash codes for this password. So security was somewhat enforced. So what Trudy or the attacker is going to do is basically do a forward search attack. So she's going to use either or consider all possible passwords or just first the common passwords that are known to be favored by users, and she's going to do some pre-computation. In particular, she is going to build a file of her own. So we're going to call this file F, and this file is basically going to contain the results of the pre-computation that Trudy is going to do. Remember, Trudy is going to take a bunch of passwords, she's going to hash them, and then she's going to remember the hash code. So why don't you pause the video and think about which information should be contained inside each one of these records in the file F. So basically, what Trudy is going to do is she's going to also have records with two components. And the first component here is going to be the hash code that she computed using the known hash function. And then the second component is going to be the password that she fed as input to that hash function. So she's going to go through a bunch of passwords, going to hash them, and then she's going to store all of these results in the file F. And then she's going to sort this file in order. Which field do you think she could use to sort the file? She should use the hash code or the password. Well, she should sort the file according to the hash code because, as we're going to see, this is the key she's going to use to index or search in that file. So again, we already assumed that Trudy obtained a copy of the system password file, so for the system that she attacked. So now all she needs to do is what? She's going to go in sequence through the system file. She's going to grab the hash code for that record, and she's going to do a search in the F file to see if she can find a match. So this is going to be pretty quick because this file is sorted by hash code. So if she doesn't find this hash code in the F file, she's going to move on to the second one and do a search of this hash code in the F file. Eventually, if she's lucky, she's going to find a hash code that matches a hash code in her own F file. And when she has done that, the attack has succeeded. Because what happens is so actually the hash code is on this side, right, in this file. So Trudy has found a match between a hash code that she computed, and therefore she knows the password that corresponds to this hash code. And because she has access to the system file, she also knows the user ID for that hash code. So in other words, Trudy was able to find the password for a particular user, and she can now impersonate that user and go through the user authentication step successfully, even though she's not that user. So notice this kind of attack is what we call a space-time trade-off situation, because notice what happens is that by pre-computing and storing all of the password hashcode pairs, she had to use quite a bit of disk space, especially if she considered millions and billions of passwords. But thanks to the space that she was able to use, she's going to speed up the search, because now every time she looks for a particular hash code, it takes almost no time to look into that file because it's been sorted according to the hash code. So in particular, she's trading space and time because she was willing to use a lot of space to reduce the time it will take to find a match. So how are we going to prevent this kind of offline dictionary attack? Well, that will be the topic for upcoming videos. But before we discuss the defense mechanisms, let's talk about different kind of attacks. So I listed 9 of them here. I'm sure you can think of others. So the one we just talked about is called the offline dictionary attack. So the maybe even more common attack is called the brute force attack, where an attacker would basically try to break into a particular user's account by trying all possible passwords. So this would be someone sitting at the computer at the keyboard and just typing in a whole bunch of passwords, or maybe having an automated system to try all possible passwords to be authenticated with. So notice those two attacks, 1 and 2, are actually different in a couple respects. So this is called an offline attack because basically you do a lot of pre-computations without having to access the system at the time of the attack, because you downloaded the system file on your own computer, and then you have all the time you need to perform this attack. This is more of an online attack where you're actually logging in or trying to log in every time through the system. So you don't have as much time, and also you don't have as many trials, because sometimes or often the system will lock you out after unsuccessful number of attacks. So that's one difference. But actually the most important difference is that in this case, you're trying all possible passwords. So it's a brute force attack, right? And you're doing it for one user because you're targeting a specific user account. Whereas in this one, okay, you're also trying all passwords, or maybe all common passwords, but you're not targeting a specific user. You're actually targeting all users in the system because you don't know in advance which user you're going to find a match for, if any. Anyway, so these are 2 different attacks. Make sure you keep them straight. Another type of attack is a popular password attack. So the difference between this one and the other ones is that you're not really trying all passwords, you're just trying popular passwords, passwords that are known to be favored by users because they are common, they're easy to remember, and so on and so forth. And again, in this case, you're targeting, so this is popular passwords. Of course, there is some overlap between these attacks, but I'm trying to give you different dimensions to compare them against each other. And in this case, you could say all users. Whereas in the next attack, the password guessing attack against a single user, then first of all, you're targeting a second user. And second of all, you're not trying all popular passwords or even all passwords in general. You're just targeting user-specific passwords. So in this case, you're using information about their name, their address, whatever personal information you know about them. Also, the policies on password that the company they work at uses, and so on and so forth. These are user-specific information. A related one here down here is the attack that exploits user mistakes. So in this case, you're also targeting a single user, and you're also using user-specific password information. But in this case, you're doing some kind of social engineering, or you're exploiting the fact that the user shared their password with maybe a family member or a coworker, or maybe they just wrote down their password on a post-it notes. So this is based on user mistakes. Other possible attacks include device hijacking. So an example of that would be, say, someone stepping away from their desktop machine and staying logged in but forgetting to lock up their screen. So someone could just come in for a few minutes and access their personal information. Another one would be to exploit the fact that the user used the same password in multiple systems. So assuming that you already broke their password on one system, then the attacker would use the same password and try it on different systems that the same user is using, hoping that they use the same password. Of course, you could do some electronic monitoring, like we discussed earlier, eavesdropping or packet sniffing on network communications, or maybe you could just do software or hardware keylogging on the user's system, and so on and so forth. I mean, another kind of attack you might not think about is a denial of service attack, say on the authentication server. It is also an attack on user authentication because it prevents the user to log into the system. So in this case, it's an attack on the availability of the system. So the bottom line is I just wanted to give you an overview of all the possible attacks on passwords. And one of the reasons why there are so many different attacks is because this password system is used widely in a large variety of systems for almost every user around the world. So I want you to keep in mind the main attacks, in particular the first three, because I might be referring to them later in upcoming videos.